In this class, we will solve a problem of finding support reactions. So you know about different types of beams. So simply supported beam, cantilever beam, overhanging beam. So they are statically determinate beams. That means the reactions can be found out using only the equations of equilibrium. So you have three equations of equilibrium for a non-concurrent force system: sigma fx0, sigma fy0, and sigma m0. So using those three equations, you can always find the three unknown reactions in any given beam. If the number of reactions exceed 3, then the beam is known as statically indeterminate beam, because we cannot solve or we cannot find the reactions only by using equilibrium equations. So fixed beam, continuous beam, proper cantilever, they are all examples for statically indeterminate beams. Now in this class, I have taken a problem from January 2020 VTU question paper, which is a composite beam. So composite beam means one beam is resting on another beam. Here you can see AB is one beam which is resting on another beam CD. So both are simply supported beams. So we can take this AB as simple supports for the beam AB and CD as simple supports for the beam CD. So beam AB is resting on beam CD. So that is why it is called as composite beam. So for the beam AB, A and B are the supports. So you can take reactions as RA and RB for the beam AB, and for the beam CD, reactions will be there at the C and D, RC and RB. So since that means there are 4 reactions here. 4 reactions. Of course, these 4 reactions you can find out using equilibrium equations for the first beam separately, for the second beam separately. So the equilibrium equations we use are sigma fy0 and sigma m0 for the first beam AB. Same thing, sigma fy0 and sigma m0 for the second beam. So by 2 equations and 2 unknowns will be there, we can easily solve. So here you can observe that in this case you have an inclined load also here. So this RA, whatever reaction RA you are going to get, it will be having 2 components, HA and VA, because he has given inclined load here. So whenever an inclined load is given on a beam, so you can take that, you can resolve that inclined load into 2 components, horizontal and vertical components, and then you can analyze. So that means this RA will consist of 2 reactions here, because he has no inclined load. So that means you need one more equation to solve this, that is sigma fx0. Whenever horizontal reaction will be there, you have to use the sigma fx0 also as one of the equilibrium equations. Now that means totally you can have 5 reactions. So of course RA is a combined reaction of HA and VA. So to find RA we need HA and VA. So therefore finally we can say that you have 5 reactions in total. So HA, VA, RB, RC and R. So you can see here on this beam CD, you have only vertical load. If there are only vertical loads, you have only vertical reactions. Only vertical reactions will develop. Now what I will do here is, to analyze the problem, I will consider the FBD of beam AB and CD separately. FBD of beam AB I will write down now. So FBD free body diagram is nothing but the diagram obtained by replacing the supports with the respective reactions, and the loads whatever is acting on the beam, they have to be considered. Now AB I am going to write. This step is very important, writing the free body diagram. Since you have inclined load given here on this beam AB, definitely this will have 2 components, horizontal and vertical component. The horizontal component of the force is resisted by the horizontal reaction. Now let me take the horizontal reaction like this, HA, and VA will be like this. So this is at point A. Then you have this 160 Newton. This 160 Newton force should be resolved. If you resolve that, you can have 2 forces like this. So this is 160 cos 30. This is 160 sin 30. So the horizontal component of the force will be like this, which is 160 cos 30. You know how to resolve. So this becomes 160 sin 30. Okay, so that is at a distance of 4 meters. So distances are also very important. So this is acting at a distance of 4 meters. Then you have a triangular load. So triangular load we have to convert into equivalent concentrated load. So I have, you know that in the case of a triangular load, so here the distance is 4 meters. The length of the triangular load is 4 meters, and the intensity of triangular load is 200 Newton per meter. So in the case of a triangular load, if you are converting the triangular load into concentrated load or point load, so we have to take a load which is acting at the center of gravity or the centroid of the concentrated load. So centroid will be there definitely here. In this case, it will be at a distance of 2/3 of 4 meters from this end, or 1/3 of 4 meters from this end. So which is the thing, but this is 8 divided by 3, 2.33 meters, or you can take 6.17 meters. That means it is 2.33 meter from this point. If I take this as E, F, G, something like this. So this is F, this is B. Okay, and this point is E. Yes. So it will be at a distance of 2.33 meters from F, from this point F, and the equivalent concentrated load is area of the triangle. Area of the triangle is half into 4 into 200, which comes out to be 400 Newton. So 400 Newton is the equivalent concentrated load, which will be acting at this point G. So I will take this as H here. Okay, G will be here. We have taken this as G. So this G will be at a distance of C here. Be careful here. From E to F it is 2 meter. From F to G it is 2.33. So therefore total it will be 2 plus 2.33, which is 4.33 meter from point E. So distances will be correctly written because we are going to take the moments later on, or using this sigma m is equal to 0 equation. Now this is the equivalent. That is 400 Newton will be acting at a distance of 4.33 meter from E. That is the equivalent concentrated load to this triangle. Now at B you have support here. That support I will take it as reaction as R. So this is how the free body diagram of beam AB is written. So what I have done here is I have replaced this hinge support by two reactions, HA and BA. I have taken HA because there is an inclined load here which has got a component of horizontal component, and that horizontal component of the force is assisted by the horizontal reaction. Therefore, HA will be there. If this inclined load is not given, instead of inclined load they give only vertical load 160 Newton, then this HA will be 0. There will not be any horizontal component, and HA value will be 0. Now, this is the free body diagram of beam AB. Now, I have to use, there are three unknown reactions here, HA, VA and RB. So those three we have to find out, HA, VA and RB. So those three are found out using the three equations of equilibrium as already told, sigma fx 0, sigma fy 0, sigma m 0. So the first equation I am going to use sigma fx is equal to 0, sign convention is force acting towards right positive. So for this FBD, if I apply this equation, HA is taken as positive because it is acting, I have assumed, towards right. This 160 cos 30 is also positive. So initially you can assume any direction. Later on, after getting the value of the unknown reaction, if it is positive, your assumed direction is correct. If it is negative, it acts in the opposite direction. So here only two horizontal forces or one reaction force, both are positive. So therefore, HA will be negative here. HA is equal to minus 160 cos 30, which will be, the value is minus 160 cos 30 will be, the answer is minus 160 into cos 30 is 138.56, minus 138.56 Newton. So the negative sign indicates that the reaction is in the other direction. So HA I have assumed like this. Naturally it will be the other direction, because force is in this direction, definitely reaction should be in the opposite direction. So this is direction of the negative sign indicates that it is acting towards that. So one reaction we got. Now the second equation is sigma Fy is equal to 0. for this the sign convention is upward force is positive, downward force is negative, including reactions. So VA is positive, it is acting upwards. 160 sin 30 is negative because it is acting downwards, minus 160 sin 30. 400 is also negative, minus 400. RB is positive, so plus RB is equal to 0. So, of course, RB is a simple support, so that therefore only one reaction will be there. So, B is a simple support. Now, this equation will be now VA plus RB is equal to 160 sin 30 is 80, 80 plus 400 is 400. So this is the equation. We cannot solve because there are two unknowns. One more equation we need. We call that equation 1. Then third equation is sigma m. Either about A or about B you can take it as 0. I will take sigma m is equal to 0. So clockwise positive, anti-clockwise negative because this is a moment. So since H and B are acting at point A only, they don't have any moments. This 160 sin 30 will be having a clockwise moment. So 160 sin 30 clockwise is positive, multiplied by the distance is 4 meters. And this 160 cos 30 will not have any moment because it passes through that point A. Then coming to this 400 Newton, so it is also giving clockwise moment, plus 400 into distance is 8.33. Please note that 4 plus 4.33, 8.33. Then distance from A you have to take. Then RB is given anti-clockwise moment minus RB into now the total distance becomes now okay. The total length of the beam is 4 plus 2 plus 4 plus 2. So totally it is 12 meters. So total it is 12 meters. So total length is 12 meters. So that means this reaction B is acting at a distance of 12 meters from A. Is equal to 0. So this is the moment equation. So we have taken the moment about due to this, and due to this. So one is anti-clockwise, two are clockwise. Now you can get the value of RB from this. So you can simplify this. 160 sin 30 is 80. 80 into 4 is 320. 320. So RB is equal to, if you bring this RB to that side, it becomes positive. So this is 320 plus 400 into 8.33 is equal to this much divided by 12. So you are going to get the value as 304.33. 304.33 Newton. So you have got positive value. That means the assumed direction of RB is correct. So if you get negative value, it acts in the opposite direction. Now substitute the value of this RB in equation 1. Substitute for RB in equation 1, you can get the value of V. So VA is equal to 480 minus RB. That is 480 minus. So 480 minus 304.32. So it comes out to be 175.67. So this is also positive newtons. That means you are doing direction of VA square. Now we have got HA and VA. So both the values we have got. You can find out the resultant reaction. You can see that HA is acting like this, VA is acting like this. Therefore your RA resultant reaction should act like this, and the alpha angle made by RA with HA is alpha. Now you can find out the resultant reaction. In the case of the hinge support, you have, if there are horizontal and vertical reactions, you can find out the resultant reaction at A by using this root of HA square plus VA square. So which is nothing but HA is 138.56, 138.56 square plus VA is 175.67 square under root. So this value will be 223.74. 223.74 Newton, and the angle alpha made by the resultant reaction RA with horizontal is tan inverse of modulus VA by HA. This is similar to finding the resultant in the case of concurrent or non-concurrent magnitude and direction of resultant. This is resultant reaction, that's all. So tan inverse of 175 by tan inverse of 175.67 divided by 138.56. So which is 51.74 degrees. So this is the reaction at A. So we have got now RB. So RB we have got, which is equal to 304.33, which is acting upwards, and RA we have got 223.74 kilonewtons, making an angle of 51.74 degree and acting in the second quadrant. The second quadrant like this, because HA is negative and VA is positive. So now after this, you can consider the beam CD, second beam CD, and we can find the other two reactions, that is RC and RD. So here RA we have got 223.74 Newton, and alpha is, both we have to find out because it is an inclined reaction. We have to find both, and RB is 304.33. Now to find the reactions RC and RD, we have to consider the free body diagram of this beam CD. So beam CD. Now let us take the free body diagram of beam CD, and we will find the reactions RC and RD. So now one step is very important here. Whatever at the point B, whatever reaction is developed at B, beam CD. So B is here like this. So you have to understand this concept here. B is a common point for both the beams AB and CD. At this B, for this beam AB, you have the reaction like this, RB. RB we have got 304.33. Now for the equilibrium of this joint B or support B, whatever you can take, so there should act a downward force of same value, 304.33 Newton. So this is very important. This concept is very important. So for the equilibrium of B, since a reaction of joint B, since a reaction of 304.33 Newton has been developed at B by considering beam AB, so that reaction would act as a force at the same joint B acting downwards to have the equilibrium. So this is the internally developed reaction. This we are going to apply to get the joint B in equilibrium. Now if I do that, I will write the free body diagram of CD now. So this step is very, very important. Here you can see that on CD you have only UDL, that is vertical load only. Therefore, the reaction at C, only one reaction, vertical reaction, and reaction at D also you have only one. Even though it is hinged, since only vertical force is acting on the beam, you have only vertical reaction, there is no horizontal reaction. So here, B point is here, the distance between this C and D is 2 meters. That has been given here, 2 meters. Now at this B, you have to take this load. When you are writing the free body diagram of beam CD, the 304.33 Newton becomes a load acting on the beam. Now, in addition to that, this UDL is there. This UDL you have to convert to concentrated load. 50 into 4, that is 200. 200 Newton is the concentrated load, which acts at the midpoint. So now I have to take the midpoint, 250 into 4, that is 200 Newton. So if I take this midpoint as I, point I, so this point I will be at a distance of, from B it will be at a distance of 2 meters plus another 2 meters here, midpoint, so 4 meters. So this is 4 meters. And the rest of the distance is this. Rest of the distance is 2 plus 2 plus 4, 2 meters. This is 2 meters. Total it is 8 meters. Length of beam CD is 8 meters. Now this is the free body diagram of beam CD for finding the reactions RC and RD. So this step is very important, where at the common joint B, whatever reaction you are going to get for the beam AB, that same reaction will be acting as a force in the opposite direction at the point B. Now there are only two reactions here, so only two equations we can use. One is sigma Fy0, another is sigma M0. So because you need not use sigma Fx0 because there is no horizontal reaction, there is no horizontal force here. So if I use this equation, sigma Fy0 for this, so Rc is positive plus Rd is also positive, minus 304.33 negative because downwards, minus 200 is equal to 0. This is the equation. Now we can write this as Rc plus Rd is equal to 200 plus 304. That means 504.33. You can call this as equation 2 now. Next number you can get. Next, one more equation is sigma MC0 or sigma MD0, any one. Either you can take sigma MC0 or sigma MD0. So your clockwise positive and clockwise negative. Like that we have to take. Now I will use sigma MC is equal to 0. At any one of the suppose you can take algebraic sum of the moments and equate them to 0. Sigma MC is equal to 0, clockwise positive. So this RC doesn't have any moment about C because it passes through C. 304.33 Newton will give a clockwise moment about C. So 304.33 into distance. Moment is force into distance, that is 2 meters. Then 200 Newton also is giving a clockwise moment plus 200 into distance is 2 plus 4, that is 6 meters. This RD is giving an anti-clockwise moment minus RD into 8 meters is equal to 0. This is the equation, moment equation. From this you can get the value of RD. So RD is equal to, if you bring it RD to that side, it becomes positive. 304.33 into 2 plus 1200 divided by 8. So the answer is 226.08. 226.08 Newton. So you are getting positive value, that means the assumed direction of RD is correct. Next, substitute this value of RD in this equation 2. Substituting for RD in equation 2, so you can get the value of RC. RC is 226.08 minus RD, that is minus, 504.33 minus RD, that is minus 226.08. The answer is 504.33 minus 226.08 is equal to 278.25. 278.25 Newton. Positive only, therefore assumed direction is correct. So these two are the reactions. So like this, you can find out all the four reactions: RA, RB, RC, RD. So RA is 223.74 Newton. We got 223.74 Newton, and the angle where we are in the x-axis is alpha 51.74 degrees. Then RB we got 304.33. The same thing is taken as a force acting on beam CD because B is the common joint. Then RC 278.25 and RD is 226.08. So here RA is acting in the second quadrant like this, RB is vertical, RC is vertical, RD is vertical. Now this is the final answer. So these are the reactions that are developed due to the externally applied forces on the composite beam. So whenever a composite beam problem is given, you should be in a position to write the pre-body diagrams of both the beams separately, and then at the common point where the first beam is resting, you are going to get a reaction. Here that point is B, and that reaction arm is taken as a force acting on the second beam. So this is how we have to do the problem. So understand the problem, work out the problem on your own and check the results. So this is an examination problem carrying 12 marks. So this carries 12 marks in the examination.